Hello, welcome. In this lesson, we're talking about polygons and then we'll solve questions like this and more. So this question says in the diagram below, first find the value of x, then find the unknown angles in each polygon. Okay, we're not going to go ahead and solve this question. We'll go through the lesson, then we'll come back and solve questions like this and more. A polygon is basically a plane figure with different sides. So the number of sides of the plane figure tells us the kind of polygon we are actually dealing with or working with. So according to the note, I said polygons are named after the number of sides they have, just like I explained. Okay, assuming we'll have a plane figure or a plane shape like this with three sides. This is a triangle, there is three sides and then three angles. Now I want us to go to this table because I want to help you do something. So we have number of polygon, number of sides, and then number of triangles. So this is the part of the table where we are going to fill together. So this plane shape has three sides, and then you know the sum of angles in a triangle is 180 degrees. That is sum of angle in a triangle. Sum of interior angles in a triangle is 180 degrees, right? Okay, so for us to find the sum of interior angles of any polygon, we use the formula n minus 2 brackets 180 degrees. So let's do that here. N talks about the number of sides of the plane figure or plane shape. So this is a triangle. It has 1, 2, and 3 sides. Now because it has 3 sides, we are going to substitute n with 3. So we have 3 minus 2 bracket 180 degrees, right? So 3 minus 2 is 1. 1 multiplied by 180 degrees gives us what? Gives us 180 degrees. So you see, it makes sense when we say that the sum of angles in a triangle is 180 degrees. Now, I'm bringing you back to this now. In a triangle, the sum of interior angles is what? 180 degrees. It simply means that we need 180 degrees to make up one triangle. So if we have 260, if we have 540, it increases the number of triangles. Okay, so I'm going to do that and then solve for like 2 questions here, then we'll get into the lesson fully. I just wanted to, be able to think about this and reason it logically like the way I'm doing right now. Okay, so here we say that the number of triangles is what? Is 1. Yes, we'll have one triangle inside this kind of polygon, exactly. So we have one triangle inside this kind of polygon. The polygon that has 3 sides has one triangle, which is same thing as 180 degrees. Okay, let's check for the next one. Assuming we'll have a plane figure like quadrilateral. So the quadrilateral has 4 sides, so 4 different sides. 4 different sides. So we'll use the formula again, n minus 2 brackets 180 degrees. But now our n changes to 4, right? So 4 minus 2 bracket 180 degrees. So that we'll have 4 minus 2 is 2, so 2 brackets 180 degrees, and bracket here means times, so 2 times 180 gives us 360 degrees. Now 360 degrees is the number of angles, but then since there is 180 degrees in one triangle, it means 2 triangles gives us what? 360 degrees. So the number of triangles here is 2. I know this might be complex to you, but I think if you pay attention, you're going to understand. So for us to make things clear, let's solve one more question. Okay, let's solve for this hexagon. So I believe you can do this one yourself. So for hexagon, for us to find the number of triangles in a hexagon, so what we'll simply do is that we'll use the formula again. Okay, so let's use the formula. The formula says, you're solving for hexagon now. So the formula says n minus 2 bracket 180 degrees, right? So hexagon says has how many sides? 6 sides. So 6 minus 2 bracket 180 degrees, right? So 6 minus 2 is 4. So 4 multiplied by 180 degrees. So I think I want to use a calculator. So we have 4 multiplied by 180 degrees, 720, right? Okay, so we have is equal to 720 degrees. Now we are not solving for degrees, we're solving for the number of triangles. Now since we are getting 720 degrees and then 180 degrees make one triangle, so we are going to divide this by 180 degrees. So doing that, I can say that 720 divided by 180, so that will give us our final value. So let's do that together. 720 divided by 180 degrees gives us 4. So exactly, there are what? 4 triangles in a hexagon. So I want you to go ahead and try that of pentagon, that of heptagon, that of octagon, nonagon, and decagon. It's just exactly the same thing. And then one more thing before we leave this slide, I want you to take your time and master this. It's not difficult. Just take your time and master name of polygons, the number of sides, and then you can be able to solve for the number of their triangles. Actually, I think there are very rare questions that will ask you for this, but just prepare for whatever comes your way. So let's go to the next slide where I'll talk more on this. Okay, so now interior angles of polygons. So I've been able to introduce this concept of interior angles of polygons. So this particular lesson is going to be focused on interior angles of polygons, and then the next lesson we'll talk about the exterior angles of a polygon. Okay, so let's go ahead and do this together. Okay, so the sum of interior angles of a polygon is equal to what? It's equal to 180 degrees multiplied by n minus 2. So let's put that down. So n minus 2 brackets 180 degrees, where n is equal to what? Number of sides of the plane shape or plane figure. So you can see this particular plane shape has 1, 2, 3, 4 sides. That is a quadrilateral, right? So this one has 3 sides, 1, 2, 3. This is a triangle. This one has 1, 2, 3, 4, 5. This is a pentagon. This one has 1, 2, 3, 4, 5, 6. This is a hexagon. Okay, so for us to solve for, let's use a pentagon this time around. For us to solve for a pentagon, what we simply do is that we are going to still employ this same formula. And what does the formula says? The formula says n minus 2 brackets 180 degrees. So why am I repeating this formula as often as possible? Because we are humans and we learn by repetition. So some of you do not need to cram this formula. By just thinking about this the way I'm thinking about it logically and practicing by repetition, you're just definitely going to remember this. Okay, so the number of sides, where n is the number of sides, right? So here we have 5, right, for this pentagon. So n becomes 5. We are substituting the number of sides for n. So the number of sides is 5. So substitute for n, that gives us 5. 5 minus 2, and then brackets 180 degrees. 5 minus 2 is 3, right? Okay, 3 multiplied by 180 degrees, and then 3 multiplied by 180. So let's do that together. 3 multiplied by 180 gives us 540, right? So equal to 540 degrees. So this is the sum of the total interior angles of a regular pentagon. Yeah, so let's go to the questions. Now we have been able to go through the basics. Let's go and solve questions. At this point I feel like you are fit to tackle some questions, so let's do that together. Okay, so calculate the size of each angle of a regular heptagon. Okay, this question is a little bit tricky. I want you to pay attention to details and I don't want you to miss out with anything. Okay, so let's do this together. Calculate the size of each. So be careful about this. Each angle of a regular heptagon. So first of all, we have to impute our formula. So oftentimes when I'm solving question, I like to write solution, but that's not compulsory. Okay, so we want to put down the formula first. The formula for solving polygon says n minus 2 brackets 180 degrees, right? Okay, so once you've been able to do this, the next thing you want to do is you want to now refer to the question. So calculate the size of each angle of a regular heptagon. So what does heptagon say? Heptagon tells you about a polygon with 7 sides. So you have 7 sides, and that becomes our number of n. You understand? So that 7 sides talks about the number of n, right? Okay, so here we can now substitute. So we say 7 minus 2 brackets 180 degrees, and then 7 minus 2 is what? Is 5. 5 multiplied by 180 degrees. So we're going to multiply since we have a bracket, or I can as well simply write 5 times 180 degrees, the same thing. So let's go ahead and do this. So 180, okay, that's 5 multiplied by 180 degrees gives us 900. So we have 900 degrees. Now this 900 degrees, I don't want you to complicate things. 900 degrees is the total interior angles, that is the sum of interior angles in this heptagon. That is the total. So I think I want to make things clear right now. So total slash sum of interior angles is equal to what? Is equal to 900 degrees. Okay, but that's not what we are meant to solve. We are meant to solve for each angle. Okay, so since the total angle is 980 degrees, for us to get each angle, we have to divide the total interior angle by the number of sides. Remember, we're not solving for number of triangle right now. If we are solving for number of triangles, what we divide by what? We divide by 180, and then that 180 tells us the number of triangle in this heptagon. But we're not solving for number of triangles, we're solving for what? The number of sides, each side of the angle. So we have to divide by the 7. So if we divide, okay, so for each side, so I can say for each, I want to continue from here. For each side, then I will have 900 degrees, or just 900 divided by 7. So let's do that together. 900 divided by 7 gives us, okay, 128.57. Okay, I want to take 2 decimal places, so 128.57. So I'm having 128.57 degrees. That's for each side. So it means if I want to sketch this particular heptagon now, it has 7 sides. So let's say your scale don't have to be perfect. So 1, 2, 3, 4, 5, 6, 7. So it means there's an angle here, there's an angle here, there's an angle here, there's an angle here. Okay, when you are drawing this, maybe in your math notes or during your math classes, I think you want to use a meter rule and then a pencil so that you can get better accuracy. It simply means that each of the angles here measures 128.57 degrees. So here is also 128.57 degrees. It simply means all the angles here have the same size, right? So let's go ahead and solve the next question. Okay, this was the question I showed you earlier, and we're going to do this together. So let's go. It says in the diagram below, first find the value of x, then find the unknown angles in each polygon. So the first step, we are asked to solve for the value of x, right? Okay, let's put down our formula first. So we'll have that sum of interior angles in a polygon is what? Is n minus 2 brackets 180 degrees. That's the sum of interior angles in a polygon, right? So after that, what's next? We know that the number of sides talks about n. So what's the number of sides here? This is 1, 2, 3, 4, 5. The order in which you count does not matter, but just make sure you get the number of sides. So this is a pentagon actually. Okay, so this is 5 minus 2 brackets 180 degrees. Okay, but then we have to equate this to the number of angles here, because the total number of angle is equal to whatever figure we have here. So let's do that together. So this becomes equal to, we're going to add all these angles here together. So we have x to x, and then because there's a box here, this box represents 90 degrees. Please don't make that mistake. Whenever you see this kind of box in geometry questions, it represents 90 degrees, this angle 90. So here we have 150. So let's go together. We have x plus 2x plus 90 degrees plus 150 degrees. Now when solving, you don't need to add your degrees when solving, but at the final answer, ensure you put your degrees. You can just solve and not include degrees. When you solve, when you're done, you cannot include your degrees. So here we have 5 minus 2 gives us 3 brackets 180 degrees is equal to, so let's add up. X plus x is 2x plus this is 4x. So 4x plus 90 plus 150. Let's not rack our brains since we have an online calculator here. So 90 plus 150, and also to save time, so we have 240, right? So 240 is equal to 80 times 3 should be 540. We've done that before, but let's still do it. Okay, 180 times 3 is 540, and even if he has also said 3 multiplied by 180 is same thing. So it's still giving us 540, and I recall because it's not been long we did that. So 540. So 540 is equal to 4x plus 240. So at this very point, what do? We can collect like terms so that we have 4x standing alone. Now mind you, even if 4x happen to be on this side of the equation, is no wrong. So for instance, what I'm trying to say is that assuming we have this equation like this, 4x plus 240 is equal to 540. It's exactly the same thing, because on the left hand side you have 4x plus 240, and then on the right hand side you have 540. What I'm trying to say in essence is that whatever your variable is, whether on the left or right hand side, is just correct as long as you're doing the right thing. It must not be on the left hand side for you to be correct. Just understand what you're doing and then solve appropriately. So let's continue. I can collect like terms here and then have, if I collect like terms, I want to move 240 this end, so I have 540 minus, because it's plus here, crossing the equality sign becomes minus 240 is equal to 4x. So 540 minus 240 should be 300, but let's see. 540 minus 240, so we have 300, right? So we have 300 is equal to 4x. So what do we do next? We have to divide both sides by the coefficient of x, which is 4x. So continue from this end. So we have 300 over 4 is equal to 4x over 4. So the 4's we cancel out, and then 200 divided by 4 should be 75 or so, but let's see. Divided by 4 is 75 exactly. So we have 75 degrees is equal to x. So therefore x is equal to 75 degrees. And the question says in the diagram below, first find the value of x. So value of x is what? 75 degrees. And then I said find the unknown angles in each polygon. So this is this angle has been found. So let me just mark out the angles that have been found so that we don't have to repeat things. This one has been found. This one is 90 degrees, so we can put it down, 90 degrees. This one gives this is 75 degrees, also 75 degrees. So this one we have to multiply this one by 2. So all we need to say is 75 times 2 gives us the next one, that is 150. So here we have this is equal to 150 degrees, and we are done. So in your booklet you can just say you can just put it down and say therefore s is equal to 75 degrees when you are solving. Okay, so let's go ahead and solve this. The sum of angles of a polygon is 1980 degrees. This should be in degrees. Okay, how many sides has the polygon? So first let's start from our formula that says n minus 2 brackets 180 degrees, right? Okay, the sum of interior angles of a polygon, so is equal to 1980 degrees. Okay, so from this very point, I think this question is a little bit more advanced and complex. What we'll simply do is that since we don't know the number of sides, so we cannot substitute for number of n, and the only thing we can do is to divide both sides by 180. So this brings us back into algebra, dividing both sides by the coefficient of the variable. But I think this is more like a complex variable here. So what I simply mean is that, look at this, I want you to pay attention to this. Pay attention to this, 180. So dividing both sides by 180 gives us, so this by 180 and this one by 180 degrees, so that it can cancel out. So cancelling this out, we're left with n minus 2 is equal to, let's divide. So 1980 divided by 180 gives us 11. So we'll have 11 here. And now mind you, this is more like solving for the number of triangles, because if you know the number of triangles, to an extent you can tell the number of sides. So if it's 180, it means it's 3 sides. Then if it increases, then you increase the number of sides of that very polygon. I think that knowledge would have also helped us very well here. So we're just solving for the number of triangles now, and we know that this is 11 triangles. We can now simplify this. But if you don't understand it that way, we can still do it this way. So from this point now, we know that you can just say n minus 2 is equal to 11. So all you simply do is collect like terms. To collect like terms here, you move this minus 2 to this end, it becomes plus. So you just say 11 plus 2 and then it leaves here. Or you can just say n minus 2 plus 2, adding 2 to both sides, so 11 plus 2, so that these two can cancel out, and then n is equal to what? 11 plus 2 is 13, and that's the number of sides. And remember I said how many sides has the polygon, so we are asked to solve for the number of sides of this polygon. Having said that, we've come to the end of this lesson. Thank you so much for joining, and do well to check out for the previous lessons, and then I think we'll solve the complex question here. And if you wish to join our community for more questions and practice and for exam prep, you are free. So thank you so much, and join us next time. See you next time. Thank you.